Yes, my dear students of ninth standard, nowadays we are discussing about periodic classification of elements, Unit 12, in your science book, Unit 12, page number 138. Already we have started and discussed about the early concept of classification of elements. The first concept was classified by Dauberiner, which is called like a Dauberiner triads in 1817. John Wolfgang Dauberiner, a German chemist, suggested a method of grouping elements based on their relative atomic masses. He grouped three elements 3 by 3 based on the atomic masses. So triads, tri means 3, so that's why the group of elements are called Dauberiner triads. Dauberiner triad, and the limitation is Dauberiner could identify only 3 triads from the elements known at that time. And also this law was not applicable to elements having low and very high atomic masses. The next classification made by Newland's law of octaves in 1866. John Newland arranged 56 known elements in the increasing order of their atomic mass. Also see, there are limitations. There are instances of two elements being fitted into the same slot, like cobalt and nickel, and this law was not valid for elements having atomic mass higher than the calcium. So this law also omitted after the inclusion of mentally periodic table. So mentally periodic table is a very basic periodic table of the modern periodic table. What is the law says? The physical and chemical properties of the elements are the periodic functions of their atomic masses. So at the time of Mendeleev, 56 elements were known. So Mendeleev arranged 56 elements known at that time according to the law of periodicity. That means according to the order of atomic masses. And there are features in the Mendeleev periodic table. Mendeleev only grouped the elements and divides the elements in the form of vertical columns and horizontal rows. 8 vertical columns which are called groups and 7 horizontal rows which are called periods. Also he divided each group into A and B having similar properties. Also elements were comprehensively classified at the time of Mendeleev, and also Mendeleev left vacant places for the new elements, and there are also few one or two limitations. That means see, the hard metals like copper, silver were included along with the soft metals, and also no proper position for hydrogen, and the increasing order of atomic was not strictly followed. When you're going to check about cobalt and nickel, tellurium and iodine, these elements were not placed in the suitable place because nickel atomic mass is 58.71, cobalt 58.93. Actually nickel should come before cobalt. Similarly iodine should come before tellurium. So the law was not strictly followed, and no uh, place for isotopic elements. These are some of the demerits, these limitations of the Mendeleev periodic table. So my dear student, now we are going to study about modern periodic table. So this modern periodic table was devised by English physicist Henry Moseley. In 1913, the English physicist Henry Moseley, through his X-ray diffraction experiment, proved that the properties of the elements depends on the atomic number, not on the atomic mass. So this is the important one. So Henry Moseley proved the properties of the elements, the properties of the atoms of the element completely based on the atomic number, not on the atomic mass. So this was proved by Henry Moseley using the experiment of X-ray diffraction experiment. So consequently, the modern periodic table was prepared by arranging the elements in the increasing order of their atomic number. So mostly arranged elements in the increasing order of atomic number. So atomic number is the basis for the classification of modern periodic table. Then this modern periodic table is the extension of original Mendeleev periodic table, known as the long form of periodic table. So English physicist Henry Moseley completely devised the modern periodic table on the basis of Mendeleev periodic table. The only difference is Mendeleev followed the increasing order of atomic mass, but Henry Moseley followed the increasing order of atomic number. This is the only difference. And also this modern periodic table, also known as long form of periodic table. Now, so in this atomic number is important. So what is atomic number? Atomic number already you learn. Atomic number is nothing but the total number of protons present in the nucleus of an atom. The total number of protons present in the nucleus of an atom. Also we can define the same definition in another term, that is the total number of electrons revolve around the nucleus of an atom, because an atom, the positive charge is always equal to the negative charge. That means the number of proton is always equal to number of electron. Number of protons are always equal to number of electron. So the physical and chemical properties of elements depends not only on the number of proton but also on the number of electrons and their arrangement. So this arrangement is called the electronic configuration. Electronic configuration is nothing but the distribution of electrons in different atomic orbitals. The distribution of electron or the arrangement of electron in a different atomic orbital is called electronic configuration. So the modern periodic law says the chemical and physical properties of elements are the periodic functions of their atomic number. This is the modern periodic law. Sometime will be asked in 2 mark question. Define, state modern periodic law. The chemical and physical properties of the elements are periodic functions of their atomic number. The last word number, atomic number. So when you go to check the Mendeleev periodic table, Mendeleev periodic law, the last word instead of atomic number, atomic masses are given. Here atomic number is given because atomic number is the basis for the classification of modern periodic table. So based on the modern periodic law, the modern periodic table is derived by Henry Moseley. Then what are the features of modern periodic table? What are the features of modern periodic table? So in the modern periodic table, all the elements are arranged in the increasing order of atomic number. All the elements are arranged in the increasing order of atomic number. So atomic number already you know. Atomic number is nothing but that is the total number of protons or electron present in the atom. Then also according to the Mendeleev periodic table, Mendeleev periodic law, there are groups and periods. So the horizontal rows, the elements present in the horizontal rows are called periods. So totally there are 7 periods in the modern periodic table, and the elements present in the vertical columns are called groups. So the elements are placed in period based on the number of shells in their atom. The vertical columns, element present in the vertical columns are called groups. Starting from top to bottom are called groups. There are 18 groups in the modern periodic table. There are 18 groups in the modern periodic table. So how many periods? There are 7 periods and there are 18 groups. So based on the physical and chemical properties of the elements, they are grouped into various families. And see table 12.5 discussed about the groups in modern periodic table. Group families. The first groups are called alkali metal. Second group elements are called alkaline earth metal. 3 to 12 are called transition metal. 13th group is called boron family. 14th group is carbon family. 15th group nitrogen family. 16th group oxygen family or chalcogen family. 17th group halogens. 18th group noble gases. 18th group noble gases. So based on the properties, chemical properties, the elements are grouped into different families. Now you can study about the periodic table. This is the modern periodic table. This was devised by Henry Moseley based on the increasing order of atomic number. You see here group 1, there are number 1 2 3 4 from top to bottom. These 7 numbers indicate period. So there are 7 periods, and there are 18 groups. So vertical columns are called 18 groups. So 1 to up to 18 groups are there. So now see, the first group elements are hydrogen, lithium, sodium, potassium, rubidium, cesium, francium. Second group beryllium, magnesium, calcium, strontium, barium, radium. Third group strontium, yttrium, and also 57 to 71, which are called inner transition elements. That's called lanthanide series, which are kept bottom of the periodic table. Then La means lanthanide. Then 89 to 103 also called actinide series because of the similarity of properties. So Henry Moseley placed these 14 elements below the periodic table, below the lanthanide. So next to see fourth group titanium, zirconium, hafnium, rutherfordium. Then fifth group vanadium, niobium, tantalum, rubidium. Then sixth group chromium, molybdenum, tungsten, sysbosium. Then seventh group manganese, technetium, rhenium, borium. Eighth group iron, ruthenium, osmium, hazium. Ninth group cobalt, rhodium, iridium, metallium. Then 10th group nickel, palladium, platinum, dysprosium. Then 11th group copper, silver, gold, and strontium. 12th group zinc, cadmium, mercury, copernicium. And 13th group boron, aluminium, gallium, indium, thallium, and niconium. And 14th group carbon, silicon, germanium, tin, lead, and that is which is called fluorovium. Then 15th group nitrogen, phosphorus, arsenic, antimony, bismuth, moscovium. Then 16th group oxygen, sulfur, selenium, tellurium, polonium, livermorium. Then 17th group fluorine, chlorine, bromine, iodine, estridine, and tungsten. Then the last group, which are called rare gases, noble gases: helium, neon, argon, krypton, xenon, radon, and ignition. So these are the elements in the long form of periodic table. Also below the long form of periodic table, mentally if kept so below the periodic table, mentally kept lanthanides and actinides. Lanthanides 14 elements, actinides 14 elements, which were kept below the long form of periodic table because of the similarity in their physical and chemical properties. Because of this similarity in their physical and chemical properties, he kept the elements below the long form of periodic table. Below the long form of periodic table. Now, so you have to go through up to this, the students, and up to that from the beginning, that is modern periodic table. Who devised the modern periodic table? Henry Moseley. What is the experiment he used for the uh, classification? X-ray diffraction method. What is the basic principle? Increasing order of atomic number. Then what is atomic number? Then what is state? Modern periodic law. The chemical and physical properties of the elements are periodic functions of their atomic number. Then what are the features of modern periodic table? And the tabulation discuss about the various groups in modern periodic table. So after this you have to revise. The next 12.2.3 classification of element into blocks will discuss in the next section. So complete your classwork and revise up to finish. Thank you. God bless you.